The theater buzzes with life, a sold-out premiere night. Laughter and applause fill the air until silence falls. An actor collapses, poisoned in the spotlight. Seat numbers, snack sales, and secret backstage swipes. They hold the clues to this deadly change. Step inside with me. Together, we will find the truth.
Hi, welcome to this crime case. Let's solve this mystery together. We have three key datasets: seat allocation, snack sales, and backstage access logs. Each one could hold a clue. Our goal? Find out who tampered with Victor's drink and why. Ready to dive in? First, let's load our data. We need to see what's inside each file. This helps us spot patterns and possible suspects. Every detail could matter. First things first, we need the right tools for our investigation. By typing import pandas as PD, we're bringing in the pandas library. Think of pandas as our digital detective's notebook. It helps us organize, search, and analyze all the evidence or data we'll uncover. Let's start by pulling up the seat allocation records. Here, I'm creating a variable called seat_DIF and setting it equal to pd.read_CISV, which means we're reading in a file named seat_allocation.csv. This file holds the master list of who sat where, crucial for tracking everyone's movements at the scene. Next, I'm loading in the snack sales data. By creating snack_df with pd.read_CSV, we're grabbing another file. This one logs every snack sold during the event. Sometimes the smallest purchase can reveal the biggest clue. Now, let's not forget the backstage access records. Here, backstage_df is set to the contents of backstage_access.csv. This tells us exactly who slipped behind the scenes and when. In any good mystery, the backstage is where secrets hide. All right. Time to lay out the evidence. With print open parenthesis, seat allocation : close parenthesis, I'm sending a clear label to the screen, so we know exactly what data we're looking at next. It's like putting a heading on our case file. Now let's reveal the seating chart. By typing print open parenthesis, seat_df close parenthesis, I'm displaying the entire seat allocation table. In Python, print is how we show information to ourselves or others, and seat_df is our variable holding all those details. Let's see who was sitting where when the crime went down. Moving on, I'm adding another label with print open parenthesis \n snack sales : close parenthesis. That \n at the start, it just means we're adding a line break, so the next section stands out. Organization is key when you're piecing together a puzzle. Let's dig into the snack sales now. By printing snack_df, we're bringing all those tasty transactions into the spotlight. Maybe someone bought a snack at just the wrong or right time. And now another label. Print open parenthesis \n backstage access : close parenthesis. Again, that \n gives us a fresh line, making it easier to separate each piece of evidence as we go. Finally, let's expose the backstage access records. By printing backstage_df, we're laying out every entry and exit behind the curtains. This is where we might spot someone sneaking around or hiding something. Let's keep our eyes peeled for anything unusual. Now, let's look at what we've got. The seat allocation file shows who sat where, their ticket type, and when they arrived. Snack sales tell us who bought what, when, and where. The backstage access log shows who went backstage, their role, and the time. Each dataset could reveal a hidden clue. Let's dig deeper. Backstage access is key. Only a few people could get close to Victor's water bottle. Let's see exactly who had access and when. This could narrow down our suspect list. Alright, before we dive in, let's make sure we're reading the clues correctly. Here, I'm reminding myself, we need to convert the swipe underline time into a format Python can actually understand. That way, every entry and exit is crystal clear down to the minute. Now, watch this. I'm taking the swipe underline time column from our backstage underline data underline frame, and I'm using Pandas to underline datetime function. That's a tool in Python that turns a string like 22.15 into a real-time object. I'm telling it exactly what format to expect, hours and minutes, so there's no confusion. Then I grab just the time part so we can line up everyone's movements. This step is key for matching alibis to the timeline. Next, I'm creating a new variable called backstage underline access. Here's what's happening. I'm dropping any rows where the swipe underline time is missing, because if there's no timestamp, it's just noise. Then I'm sorting all the records by swipe underline time so we can see minute by minute who entered or left the backstage. This helps us spot anyone who might have slipped in or out at a suspicious moment. Finally, let's pull up the entire backstage underline data underline frame and take a look at what we've got. This is our master list. Every swipe, every person, every possible clue. From here, we'll start piecing together the timeline of the crime. Look closely at this clue. Only Elena Marsh, Lydia Frost, Maya Lin, and Samir Patel had backstage access around the critical time. Tom Reed never went backstage. Our list of suspects just got smaller. Victor was poisoned through his water bottle. So, who bought bottled water around the interval? Let's check the snack sales for this detail. This could be the break we need. First things first, let's get our timeline straight. Here, I'm converting the time column in our snack underline df. That's our main data table into a proper time format. In Python, we use something called Pandas to handle data like this, and to underline datetime helps us turn those time strings into real usable time objects. That way, every snack purchase has a precise timestamp and we can spot anything out of the ordinary. Now let's narrow our focus. I'm creating a new variable called bottled underline water underline buyers. This line filters our snack underline df to only include rows where the item is bottled water. In Python, this is called Boolean indexing. We're basically saying, show me everyone who bought bottled water. Could be nothing, or it could be our first clue. Let's take a closer look at what we found. By typing bottled underline water underline buyers, I'm asking Python to display all the records we just filtered. This way, we can see exactly who bought bottled water and when. Maybe there's a pattern, or maybe someone's trying to cover their tracks. Here's what we find. Elena Marsh, Maya Lin, and Samir Patel all bought bottled water between 2010 and 2013. Lydia Frost only bought a chocolate bar. Could one of these bottles have been swapped with Victor's? Let's keep going. Now let's compare the timing. Did anyone buy bottled water and then go backstage soon after? This could show opportunity. Let's line up the snack sales with the backstage entries. Let's start by setting our sights on the next step. We're about to join the snack sales records with the backstage access list using the names as our link. This will help us see who bought bottled water and also slipped backstage. Could be a crucial connection. Here, I'm creating a new variable called merged. That's just a container to hold our combined data. We're using the Pandas library's merge function, which is like matching puzzle pieces together. We're telling Python to line up the bottled underline, water underline, buyers with the backstage underline access, matching up the buyer underline name from one list with the name from the other. The how equals inner part means we only keep the names that appear in both lists. So only people who bought water and had backstage access make it through this filter. Let's see who's on that exclusive list. Now I'm narrowing down the evidence. From our merged data, I'm picking out just the columns we care about. Buyer underline name, time, swipe, underline time, and role. This helps us focus on who did what and when. It's like zooming in on the most telling details of the crime scene. And here's the moment of truth. I'm displaying the merged data so we can examine the suspects side by side. Let's see if any patterns or oddities jump out. Keep your eyes peeled. The next clue might be right here. Here's what stands out. Elena Marsh bought water at 2010, then accessed backstage at 2015. Maya Lin went backstage before buying water. Samir Patel bought water but entered backstage later. Only Elena's timing lines up perfectly. Suspicious, isn't it? Let's make this even clearer. We'll visualize the timeline of bottled water purchases and backstage entries. This will help us spot any overlaps or suspicious patterns. First, we need to prepare the data. First things first, we need to bring in some tools. Here, I'm importing date and datetime from Python's datetime library. Think of these like our digital magnifying glass. They'll help us examine exactly when things happened, down to the minute. If you're new to Python, importing just means we're grabbing some pre-built code so we don't have to reinvent the wheel. All right, here's a little note to ourselves. We're about to add a reference date. This will let us line up all the times on a single timeline. Super handy for spotting when things go off script. In Python, anything after a hashtag is a comment, so it's just for us, not the computer. Now, I'm setting up a variable called ref_date. I'm giving it the value of January 1st, 2000. This date doesn't mean anything special in our case, it's just an anchor, a starting point, so we can plot all our times on the same day. In Python, a variable is like a labeled box where we store information we'll need later. Let's get clever. I'm creating a new column in our merged data called purchase_dt. For each entry, I'm combining our reference date with the time of a purchase. That way, every purchase now has a full date and time, even if we only had the time before. In Python, apply lets us run a little function. In this case, a lambda or mini function on every row. It's like stamping each clue with a precise moment in our investigation. We're doing the same trick again, but this time for swipe_dt. That's the moment someone swiped their card, maybe to enter or exit a room. By combining the reference date with each swipe time, we can line up these events on our timeline. This helps us see if anyone's movements don't quite add up. And now let's take a look at our merged data. This command just shows us the table with all our new date and time columns. It's like laying out all the evidence on the table ready for us to spot the patterns and maybe, just maybe, catch our culprit. Now let's build the data for our timeline chart. We'll connect each person's water purchase to their backstage entry. This will help us see who had the perfect window of opportunity. Let's start by setting up two empty lists, X_lines and Y_lines. Think of these as our detectives' notepads, ready to jot down the timeline and the names of everyone involved. In Python, a list is just a way to keep track of a bunch of things, like clues, all in one place. Now we're diving into the evidence. For each row in our merged data, we're looping through every record one by one. That's what this for loop does. It lets us examine each suspect's movements. We grab the purchase_dt and swipe_dt. Those are the timestamps for when someone bought something and when they swiped out. We add these to our X_lines list with a none in between to break up the lines later. For the Y_lines, we're recording the buyer_name twice, so we can draw a line from the start to the end of their activity. That none at the end, it's like lifting our pen before drawing the next suspect's timeline. Let's take a peek at what we've gathered so far. By printing X_lines, we're revealing the timeline of all these transactions. Every purchase and swipe laid out for us to inspect. In Python, print just means show me what's inside this variable. And now let's do the same for y underlined lines. This will show us the names connected to each event, so we can see exactly who was where and when. It's like pinning names to a timeline on our investigation board. And with Python's print, we get to see it all unfold. Now let's bring the timeline to life. We'll create a chart that shows each suspect's actions. This visual could reveal the smoking gun. First things first, we need the right tools for our investigation. Here, I'm importing Plotly's graph objects as go. Think of this as grabbing our detective's magnifying glass. It'll help us visualize the timeline of every suspect's movements. Now I'm creating a new figure with go.figure, which is like opening a fresh case file. This is where we'll pin all our clues, every purchase, every swipe, all in one place. Let's add a little context to our evidence board. These gray line segments will show the interval between when someone bought a snack and when they swiped backstage. It's like drawing strings between two pins on our timeline, connecting the dots between actions. Here, I'm adding those gray lines to the chart using go.scatter. The x underline lines and y underline lines variables hold the coordinates for each line, basically the start and end times for every suspect's activity. By setting mode to lines, we're telling Python to just draw the connections, not the points. The color's gray to keep it subtle, and we're skipping hover info so the lines don't distract us from the real clues. Next up, let's highlight the moment each suspect made a purchase. We'll use blue circles for this, so every time you see one, that's someone buying water. It's like marking the exact moment a clue was planted. Now I'm adding those blue circle markers to our figure. The x-axis is merged bracket purchase underline TT. That's the purchase date and time for each buyer. The y-axis is merged bracket buyer underline name, so we can see exactly who made each purchase. By setting mode to markers, we're only showing the dots, not connecting them. The marker dictionary lets us style the dots as blue circles, and we're adding a little extra info, the suspect's role, so when you hover, you get more context. It's like putting a sticky note on each clue. But purchases aren't the only thing we're tracking. Now let's mark the moment each person swiped backstage. We'll use red squares for these, a bold color for a bold move. Every red square is a potential lead. Here, I'm adding those red square markers to the chart. The x-axis is merged bracket swipe underline DT. That's when the backstage swipe happened. The y-axis is still merged bracket buyer underline name. So we're lining up each swipe with the right suspect. Again, mode is markers, but this time the marker is a red square. We're also including the role for hover info, just like before. This way, we can spot patterns. Who bought, who swiped, and when. Alright, time to tidy up our evidence board. Let's format the layout so everything's clear and easy to read. A well-organized chart is like a well-organized case file. It makes the truth easier to spot. Here, I'm updating the layout with a title, Snack Purchase versus Backstage Entry, so we know exactly what we're looking at. The x-axis is labeled time, the y-axis is buyer, and I'm adjusting the margins for a little breathing room. The legend's set to vertical, tucked up in the top right, so we can quickly see what each color and shape means. It's all about making our clues stand out. And that closes out our layout settings. With this parenthesis, Python knows we're done updating the chart's look. Every detail matters in an investigation, even the punctuation. Let's make the timeline even clearer. We'll format the x-axis ticks to show hours and minutes, so we can spot exactly when things happened. Sometimes the smallest time difference can crack a case wide open. Here, I'm telling Python to format the x-axis ticks as hours and minutes using tick format equals %H:% %M. This way, Every clue on our timeline is precise. No more guessing if someone slipped backstage at 8 or 8:15. And now, the big reveal, fig.show. This command brings our entire investigation to life, displaying the chart with every clue, every suspect, and every suspicious move. Let's see what the evidence tells us. Look at the chart. Elena Marsh's water purchase and backstage entry are almost back to back. The other suspects have bigger gaps, or the order doesn't fit. Elena had the perfect chance to tamper with Victor's bottle. But is that enough to solve the case? Here's our conclusion. Elena Marsh bought bottled water at 2010, then entered backstage at 2015, right before Victor's fatal drink. The other suspects' timings don't match as closely. Elena, as stage manager, also knew about the last-minute script change. All the evidence points to her. Case closed, or is there still a twist waiting in the wings?